In this course, we're going to look at a number of different convex hull algorithms. One reason is that each convex hull algorithm teaches us a new technique and something new. Previous algorithm is incremental, which meant that we add the points one by one, and we had an invariant that says at the ith iteration we have computed what we wanted, so therefore at the last iteration we have computed what we wanted on the entire input. Okay. So what is divide and conquer? Divide and conquer is the other paradigm of algorithm design. An example of divide and conquer algorithm is a merge sort, where you partition your input in two, you recurse on the left and the right, and then you merge them. And this algorithm is extremely similar to merge sort, right? At the high level, it's essentially exactly identical. Find the middle point, let's say the median, let's say that's the median x value. You cut into two halves, the left point set and the right point set. Compute the convex hull, or in this case, upper hull of the left and the right. So for example, this picture, and then somehow merge them together. And once you merge these two things together, then you have the upper hull of the entire point set. So there is really nothing too interesting about this algorithm except for the last step, right? Finding the median, well, that is part of the algorithms and data structure course. We know we can do it in linear time, or if you are lazy and if one nice heuristics, you can just randomly sample an element and you can take that x coordinate to be the x coordinate of the median, right? And that works pretty good on average. So we're not going to talk about step one because that's you should have seen this before. Step two is just a recursion. So the only interesting part is step three. So how do we merge two upper hulls? Okay. The first observation that we can make here is that this upper hull, the merging is equivalent to finding a common tangent between these two upper hulls. Okay. In general, when you have convex shapes, so let's say you have a convex shape like this and another convex shape like this, okay, you could define four tangents or four common tangents between them. So I'll show you the outer tangents. So there are two outer tangents that look like this. And then there are also two inner tangents that, like, okay, I can draw that look something like that. Okay, so if I have two disjoint or two separated convex objects, I have four tangents. And what we're looking here is the upper common tangents between the two convex hulls. Okay, and you'll see from the picture. So let me draw it again. So if I have two upper hulls, or two convex hulls, and I want to merge them, when I look at the upper common tangents, and let's say I compute the outside tangents, then the merging of these two convex hulls can be easily done by just cutting off the convex objects at the tangency points. So you cut them off here. You discard these middle guys. So this middle part is deleted. You can delete the middle part of this picture. And then you only keep the other part, right? And then with these two tangent line segments, if you add them and if you use them to glue these together, then you get the convex hull of the entire point set. Okay, so for the upper hull, we just need to look at the upper common tangent, and then we merge these two things together. So a pictorial that would look like this. After finding this, we keep these dark red parts, and we delete these middle parts. In other words, the merging step reduces to finding common tangent between two upper hulls. So now the question is, how do we solve it? How do we find common upper tangent between two convex polygons? There is an easy way to do it that it's kind of tricky. Okay, but before going the easy way, let me show you a bunch of pitfalls. So I would like you to think about this and see if you can manage it. Just pause the video and think about it for a bit. The reason I'm asking this is because one of the common misconceptions, or one of the common things that people say, is that they think that the point with the highest y coordinate is going to be the upper tangent. But that's not true at all. in general, I mean, it's actually quite easy to come up with counterexamples. So let's say I have a convex object like this. Yeah. Take any point. So let's look at the upper hull, right? So that's the upper hull, some upper hull. Just delete the lower hull. Pick any point on the upper hull. Let's say that point. Okay, let me change my colors. So let's say that point. Oops, where's my color? Let's say that point. And draw a line tangent to that point along that guy. Okay. Then you can create another upper hull that is tangent to this red line, and you have a common tangent between them. Okay. So like this. In other words, any point, if you just look at one upper hull, any point on the upper hull could be the undercommon tangent between that convex object and some other convex object. So there is no general rule whether it is the highest point with the highest y coordinate, the point next to the highest y coordinate, the point at the 45 degree, or whatever. There is no general rule. If I just look at this shape, any point of this upper hull could be a point of common tangency between this and that. It could be, so okay, so here this is on the left, but I could also do the same thing on this half, and I could just create this picture, right? So now that is a point of that's a common undercommon tangent. So there is no general rule. So how do we find this? I'm going to look at that in the next